Upon initialization of the software, an average surgery with workflow information can be loaded. Several surgeries from our database can be loaded for synchronized playback and workflow analysis. Timelines of average and original surgery are connected through the so-called dynamic time warp path, which can be seen in the left column. The right column offers different view modes of the loaded surgeries. A drop-down menu allows to jump to a certain workflow step of the surgery. As an example, we choose to watch the clipping and cutting of the first gallbladder vessel. The videos run synchronously, although the actual clipping action takes place at entirely different time points in the individual surgeries at around 7 or 16 minutes. Two different clipping techniques are demonstrated by the surgeon. The upper video shows how an artery is clipped 3 times before it is cut. In the lower video, the vessel is clipped only once. The lower video waits until the upper video is finished with the clipping. The common action of cutting the vessel is displayed simultaneously again. While 3 clips in the upper video are enough to conceal blood flow, the vessel in the lower video is sealed by electrocoagulation. This demonstrates the capability of our system to correctly classify actions within multiple surgeries into distinct workflow phases. The video playback elegantly respects slight differences in the workflow. Right now you can watch the synchronized playback while the second main vessel is clipped and cut. Again, these actions were performed at different time points in the original surgeries, namely at 9 and 19 minutes. At the right side of the video, small icons visualize the type of instruments that is in use right now. This information is read from instrument state vectors, which are read from the database for each second of the procedure. One application of the visualization software is to compare the skills and styles of several different surgeons. This video segment shows how 2 surgeons package the gallbladder into the plastic retraction sac. The lower video demonstrates the performance of an inexperienced surgeon during this activity. He needs several attempts to push the gallbladder into the plastic sac. The coordination of the 2 graspers and the positioning of the gallbladder in the retraction sac are still imperfect, so that it slips out several times. The surgeon needs several attempts to extract the gallbladder. The upper video demonstrates the performance of a senior physician with profound surgical skills. Since he needs considerably less time to package the gallbladder, the video freezes and waits so that the packaged gallbladder is shown simultaneously again. In contrast to the other surgeon, the guidance of the instruments is very precise, and he only needs 1 attempt for the packaging. This application is useful for education purposes and reviewing of surgical performance. Various data sources are available for display in our software, among which is a top view of the OR in which the position and orientation of the surgical staff is displayed. The positioning data is extracted from up to 3 external video recordings of the surgery site. The layout view serves as a hub to switch between the video perspectives. Alternatively, menus help the user to navigate between the different view modes. Each surgery consists of an extensive dataset. It contains up to 3 external videos of the surgery site. In addition to that, each dataset features a laparoscopic video stream of the surgery. Instrument state vectors over time represent each surgery in an abstract way. They allow us to synchronize the surgeries and obtain the time warp paths on the left. 3D pose information of the surgical staff allows us to analyze the layout of the OR. Video streams, 3D position information, the multidimensional state vectors, as well as the average surgery, the time warp paths, and the workflow information are all stored in a comprehensive database. So far, our database contains datasets of 6 surgeries. Together with the visualization software, we have a powerful tool available for the analysis and evaluation of surgical workflow in minimally invasive environments. This allows us to conduct extensive and unprecedented research activities during this and future projects with our clinical partners.